Hello and welcome to this new step 10 on deep neuroevolution. You can probably hear by the sound of my voice that I'm super excited to start this last step before, of course, the final race between the artificial intelligence versus the human intelligence, meaning us. And the reason why I'm so pumped about this new step is because deep neuroevolution is the next big thing in artificial intelligence. It has already started, of course, but the techniques that are being developed by AI scientists are going to make a huge impact on artificial intelligence, and especially to train the models with the optimal parameters. Because this is what deep neuroevolution is all about: finding the optimal parameters of some models. Whether it is a simple model, a single layer linear model, as it is the case of our controller, or complex models such as deep neural networks, where you have to figure out the best architecture, and with the optimal number of hidden layers and the optimal number of neurons inside the hidden layers. Well, these numbers, which so far were figured out through experimentation and through what we call the job of an artist, well, this year they will be figured out thanks to these techniques of this deep neuroevolution branch. So, speaking of these techniques, the most famous ones today and the most powerful ones are evolution strategies, not genetic algorithms. Genetic algorithms are like the oldest algorithms in that branch, but still they can provide great results. But of course, this is not what we'll use for our controller to train it to, return the best actions to play in the environment in order to maximize the final cumulative reward. But you have to know about them because they're like the basics of deep neuroevolution. And sometimes, if you are working on not a too complex problem, well, genetic algorithms will be way enough. But you have to know, of course, about the powerful evolution strategies techniques. And there are two very powerful ones today, which are CMAES, Covariance Matrix Adaptation Evolution Strategy, and which is the evolution strategy technique we'll use for our controller. And you have another one, which is PEPG, Parameter Exploring Policy Gradient, and which is even more powerful because indeed it is the optimal technique to use when you have a lot of parameters, like thousands of parameters. But here for our controller, you understood that it is a simple model. Remember, it is a single layer linear matrix. Therefore, we don't have thousands of parameters to optimize, meaning to find the optimal values. And therefore, that's why we're going to use the CMAES optimizer, right? So remember, the basics of deep neuroevolution are genetic algorithms. And then the two most powerful and state-of-the-art techniques in deep neuroevolution are first CMAES, which you're going to use when you have not too many parameters, and PEPG, which you're going to use when you have lots of parameters, like thousands of parameters. And then you have more options. You have some other evolution strategies techniques, like the OpenAI ES technique, which you will see is based on the same idea, but for which one of the details will change. We'll see what it is exactly. But that's another option of a very powerful ES optimizer, which you will also have in the toolkit. All the optimizers I'm mentioning will be provided in a toolkit that I will introduce in the next couple of tutorials. Alright, and well, speaking of all these optimizers and the toolkit, well, the way we're going to tackle this final step 10 is through, of course, the best resource I recommended to you in the very first tutorials of this course, which is this visual guide to evolution strategies by the same author of the code. Remember I introduced him to you, David Ha. He is the inventor and the developer, along with Jordan Schmidt-Huber, of the full world model, and he is also the one who made this amazing post on evolution strategies, which gives an amazing and crystal clear explanation of evolution strategies. And on this intuition level, so you will clearly get the intuition of evolution strategies and also a little bit of math actually, but still clearly and very well explained on all the techniques and optimizers that I've mentioned. So we're going to go through it, and at the same time we will go through the toolkit containing all these optimizers, and which I've prepared here in the other folder of the AI Masterclass folder, meaning the training folder, because indeed it has nothing to do in the inference folder. Inference is only about predicting the actions on a certain game, on a certain race. And training is, of course, to train all the models, including the RNN, the VAE, and of course the controller, with the optimizers. However, you have to understand something important. The evolution strategies techniques that we're about to cover only optimizes the parameters of the controller. Only the controller. Then the VAE and the MDN RNN will be trained only using classic optimizers like the Atom optimizer with stochastic gradient descent. That's what you've seen when implementing the VAE and the MDN RNN. Remember in the training operations, we introduced that Atom optimizer by TensorFlow, and it is this optimizer that will train the VAE to, produce more and more accurate latent vector Z's and more better and better reconstructed images inside the dream. And then the MDN RNN, same, will be trained using an Atom optimizer, as it is the classic way of training a recurrent neural network. But the controller, which I remind is a single layer linear model, as stated here, will be optimized thanks to the evolution strategies technique. Meaning that the evolution strategies technique will find the best parameters inside this matrix WC to return the best actions to play when getting as input the latent vector Z coming from the VAE and the hidden state coming from the MDN RNN, right? So it's really important to understand this. ES is only applied to the controller, and the goal is to maximize the expected cumulative reward of the agent. So now, back to our code. Well, I was telling you that this toolkit of all these optimizers is contained, of course, in the training, because that's only used to train the controller. And therefore, here is the toolkit, the ES toolkit, which was once again made by the same author, David A. You can find it on the GitHub. I only restructured it a bit and provided all the comments to explain what each code section does. And we're going to go through it now. I'm going to show you all the optimizers that you have and that you can use for your own reinforcement learning problems that you're solving for your work. So it doesn't have to be a problem solved by the full world model. All these optimizers here, you can use them for many other models. So it's good that you can have it and have basically some options, because for some problems one optimizer will do better than others, and for other problems, well, the best one will be another optimizer. So you need to have several options. And also, you not only have the evolution strategies optimizers, you also have the classic ones, like, as you can see, the basic stochastic gradient descent optimizers. So another important thing to understand here is that actually the ES optimizers are directly an alternative to stochastic gradient descent. It is clearly explained in the article, but you will see that actually PEPG combines SGD to the evolution strategies technique. So it is like a hybrid optimizer. Once again, hybrid AIs, I remind, is the next trend in artificial intelligence. So you have the basic SGD, you have the momentum SGD, like a more advanced version of stochastic gradient descent. You have the Atom optimizer, of course, the best one and the most classic one, and actually the one used for the training of the VAE and the RNN. Then you have this one, which is the one used to train the controller, the covariance matrix adaptation evolution strategy, CMAES. So I remind, it is the best one to use for complex problems, but with not that much parameters. When you have more parameters, you will use the PEPG, which you will find below. But all the CMAES optimizer is built here. However, you can see that we actually take it from a pre-built-in class, which is the CMA evolution strategy class by this CMA package. It is actually a package that we will install through our terminal at the very end before starting the race between the AI and the HI. So you don't have all the details here for the CMAES. However, you have all the details for the other optimizers, like this one, the genetic algorithm one, which no worries, we will see and explain together through the post, because indeed here to construct the genetic algorithm optimizer, we're not importing any package, we're building it from scratch, and you have all the comments which explains what the code sections do. And besides, I clearly highlighted the parallel between the comments here and what the author explains in the article. We will see that very soon. We will do the parallel by going through the article. Alright, so that's the simple GA, and then you have the OpenAI Evolution Strategy Optimizer, that we call here OpenES. So that's another great one. The author will explain when to use it, in which kind of situation. And then finally, as I told you, you have the PEPG Optimizer. It is very, very powerful one, a good option to have when you have many parameters, like thousands or even tens of thousands of parameters to optimize, meaning to find the optimal value. So again, it is built from scratch. You can see that it is pretty advanced. And as I told you, it combines the stochastic gradient descent optimizer like the Atom one. Atom is actually an optimal version of the stochastic gradient descent optimizer, even better than the Momentum SGD. And we will see that together in the article. It is in the section Natural Evolution Strategy. It combines indeed ES and SGD. All right, then I think that's the last one. And yes, it is indeed. You can see that this one is pretty advanced. So let's scroll back up, and now let's start our journey of evolution strategies through the post, because indeed the explanations are absolutely crystal clear.